everyone. This is the third meetup of our group, which is the BDU&UMUC University presenting the subject and sponsored by the Information and Technology System Department in the Graduate School at UMUC. The today's topic is Introduction to Python, and our presenter is
Gus Kavanaugh.
Thank you. Before proceeding, we understand that the weather is not good, that some people are going to come late, but we have to proceed with it. For your information, we also are recording for those of you who were not able to make it. So, in addition to the presenter, we have to say thank you to BDU&UMUC University for the pizza, and thank you to the Information Technology Department for arranging all this, and the refreshment in the back. Help yourself and try to get the maximum of this session.
Elena, thank you so much. My name is Gus Kavanaugh. I'm here for Intro to Data Science with Python, or Intro to Python for Data Science. I'm not sure which. Hopefully it doesn't make too much of a difference. I work for IBM. You guys are lucky enough to have me here because every other speaker they tried to bring in from Canada couldn't get a visa. So I was the last resort. And just the two sentences about me. Undergraduate liberal arts major. Did not study computer science or engineering. I'm here now because probably like many of you, I work as a government contractor for IBM. Try to use data to make better business decisions, and coding definitely helps with that. Data science is just a great way to make more money, so I think it's something we're all interested in. But I hope tonight we can cover a few topics where it will also offer practical value. What we will not be covering tonight are things related to, software engineering and probably any type of good code. So just so I will know who you are from the beginning. Do I have any software engineers in the room tonight? Okay, one, two, a couple. So I do apologize. I'm going to try. The code I will show you tonight, I believe works because I've run it myself and I've used it, but it is not. I will not claim it to be good. And I hope that can kind of be one of our underlying themes for the evening, is that you can, maybe like golf and some other things, you don't have to be good at coding and data science to derive benefit and to enjoy it. So that's kind of where we're going to go. The tool we're going to use, and that I'd like you to use to try to follow along, is called Data Scientist Workbench. So if you haven't already, please go to datascientistworkbench.com and create an account and log in. There will be a little spinning dog that will show up after you register. It might spin for 30 minutes or so. We're going to kind of go through some introductory material while that happens. What Data Scientist Workbench is a coding environment in your browser. So if you've, second question, how many people have never coded before? A couple hands, don't be shy, it's okay. Excellent. So we're going to be using an application called Python tonight. Python is an executable just like Microsoft Excel is an executable. But Python is going to read in text files that end with an extension .py. And it's going to execute those using libraries that that we've downloaded. Now, I could download these to my local machine, or if someone has put them on a server and is allowing me to access them over the web, I could use theirs. So Data Scientist Workbench is where you're using somebody else's computer where they've installed all the software to run your code. And this is a really nice thing because, one, it means you can log in and use this from anywhere. But two, it means you don't have to fill up your machine with a lot of dependencies for things you may not want otherwise. And if anyone has an interest in big data and there are specific technologies, there's software that you will use to get involved to say you're doing big data, specifically Hadoop and Spark, then installing those things on a laptop, especially if you run Windows, is really difficult. Data Scientist Workbench will have all that installed for you. So it's a huge benefit. And it's probably the only IBM product that I actually like. And I'm not pitching for it because I'm not an IBM salesperson, I'm a contractor. But I enjoy it, and it's free. And the nearest competitor is like $250 a month, so it's kind of crazy. I'm just shocked that they're still doing this. And the team who organizes this meetup, Big Data University, this is their newest addition to Big Data University. So if you haven't been to bigdatauniversity.com either, I would encourage you to check it out. Question? Absolutely. You can, yes. If you log in, and I'll show you what it looks like once you get in. If you log into Big Data University and click on Jupyter Notebooks, that's one of the options. They have a series of tutorials available for you, so you can learn not only Python but R and then some of the big data tools. So one thing you might want to do, maybe this weekend or in a couple weeks, if you forget about all this tonight and want to explore it again, they've put together a series of introductory tutorials on data analysis. So introductory data science using Python, and you can just click on any of these, open them up, and you can start running code. And then there's this very nice big data section with Spark. I think if you put Spark on your resume, it's like an instant extra $20,000, so check that out. Anyway, are people logging in? Are they getting here? I don't have a notebook for you to download tonight. I will post one later. I just kind of want you to follow along, type commands, type some code as you see fit, and then we'll spend some time at the end where we'll just let you go, let you loose, let you explore, and hopefully we can all kind of work together. I can walk around, we can try to solve some problems. Okay, so if you are trying to log in and you're having issues, just throw your hand up at any time, interrupt me, and we'll try to make sure you can get in. If you don't care, you don't want to log in, that's fine too. This is just what the inside of Data Scientist Workbench looks like after I've selected Jupyter Notebooks. Enough boring stuff. Yes. You can use Python locally if you'd like to. You may need to install some libraries to run. You don't have to have, the nice thing about Data Scientist Workbench is you don't have to install Python locally. But I have Python installed locally, and I'm going to be running locally on my machine tonight when I show you some code. So I had a few software engineers. Can I get a show of hands, like analysts? Like people said they do some coding. What kind of jobs do we have out here? What are people doing? Shout them out, other than my academic. I'm sorry, what did you say? Excellent, okay. Okay, excellent. So some SQL, that's probably a better question. A little SQL? Okay, some SQL. How about Python? I mean, since this is introductory to Python. Okay, great. One or two, a couple of Python. Okay. Okay, great. All right. Okay. Oops. So this is an IPython Notebook or a Jupyter Notebook. The name changed recently. It's essentially an interactive shell that you can run in your browser. By that, I just mean the shell is, you can type commands and get answers quickly, but the data itself is persisted, so you can still see it. I'm going to explain a lot of these things kind of as we go, and I hope to demonstrate some of the features of both Python and the IPython Notebook as a tool kind of as we work our way through this relatively short to medium length tutorial. But first, this is my introductory material for those of you who are still logging into Data Scientist Workbench, so you can just listen. So why data scientists, or why data science? And I mean that other than, of course, the obvious, which is salary increases. So I would put it to you that data is useful for making decisions, right? That sounds super obvious. I mean, how many people have ever worked for a place that claims to be a data-driven organization, right? I mean, it's a buzzword. It almost means nothing. But I would argue that most people aren't actually that data-driven. So, show of hands. I flip a coin 99 times in a row. It comes up heads 99 times. What's the probability that on the 100th flip it comes up heads? Come on, we all know this, right? What's the probability if you flip a coin? What do you get? I like it, right? 50%, right? So, and how did you make that judgment? How did you come up with that? Right? Two choices. Okay. So now let's say I'm going to color a little bit. I bet you $50,000 that on the next flip, the 100th flip, it comes up heads. Would you take my bet? And I'll give you 1,000 to 1 odds. I'll give you. Would anyone take my bet? With real money? Okay. Now imagine instead of talking to you, I'm talking to some like hustler, mafioso guy, Don Corleone from Brooklyn, right? He didn't take a statistics class in college. I flip a coin in front of him 99 times. It comes up heads each time. I bet him $50,000 that the 100th flip is going to be heads. Does he take that bet? Absolutely not. Why not? Exactly. 99 times it's been heads. But how come none of you said that? I thought we just said we were data-driven, right? But we all conveniently ignored the data that I just presented. We said, oh, no, I know the probability that that if you flip a coin, that the outcome will be heads. It's 50%, regardless of what just happened. So we'll break it down. We'll look at it with a little bit of basic probability. So we think the mafioso wouldn't take the bet, but let's do some math. So the probability that a fair coin comes up heads is 50%. To find the probability that we got that 99 times in a row, we can just take 50% to the 99, right? Which gives us an extremely small number. By the way, I ran this code by typing Shift-Enter or Control-Enter, and that will execute the code and display the answer below, right? So we can see this really small number, 1.5 times 10 to the negative 30th is the probability that we got 99 heads in a row. So what the street hustler would say is, that's probably not a fair coin, right? So I know this is kind of a contrived example. You're like, well, I didn't see that coming. That wasn't fair. But the idea is if we're using data to make decisions, we should be able to validate our assumptions. And we can test, is this a fair coin? The question we probably should have led with is not, what's the probability that a coin comes up heads, but what's the probability a fair coin comes back heads 99 times in a row? And we can say that probability is extremely low. So this is where analyzing data can be really helpful for testing assumptions that we make. So I've got another one of these for you. Oh. Okay. Oh, and just to be fair, for a historical kind of example, if you think this is contrived, how many people have heard of long-term capital management? I think that was the name of the hedge fund, right? The Black-Scholes model for valuing options. These guys made a lot of money. They wrote a paper, academics, on how to value options. They said they knew how to do it better than anyone else. They started a hedge fund. They made tons of money right up until they blew up. And why? Because the model didn't predict that we could have a crisis like we did in the late 90s with the value of the yen and this economic collapse in Asia. They didn't see it coming. Boom, they blew up, right? It worked great right up until the end. So when we make assumptions and we don't test them, then we are putting ourselves in a position to potentially for disaster. Okay. So you now may say, hey, your coin flip wasn't fair, right? Those weren't, you pretended like those were independent trials. Each flip was independent of the previous one. But in reality, if the coin's not fair, they weren't. Those were dependent events. So let's give an example with independent events. And we can see how good we are at estimating probabilities. Okay, so let's say I have two kids. Each child is equally likely to be biologically male or biologically female. And we know that the biological sex of the second child is independent of the sex of the first. So if my older child is a female, what is the probability that both children are girls? Maybe I led a little strong with the first one. So the oldest child, we know that what's the probability of one child that it's a boy or a girl? We're saying it's 50%, right? The oldest one is a girl. What's the probability that the next child is a girl? 50%. Yeah, absolutely, right? Absolutely. So now I'm going to change the question. So what's the probability that both children are girls given that at least one of the children is a girl? I'm not saying, not the older one, at least one. So I'm hearing a few murmurs. How many people think 50%, right? Okay, that's what I would have thought too. How many? I heard 25%. How many people think 33%? Okay, excellent. Why? 33% is the correct answer. Why? Yes. Bravo, bravo. I would actually give you a hand. I think that's fantastic. Thank you. This question came into the Ask Marilyn column several years ago, and it was one of the largest reader responses she got from many people, including PhDs, who she said the answer was 33%, who responded and said, "You're absolutely wrong. It's 50%. Don't you understand how independent events work?" So let's demonstrate that, and we'll walk through it logically, as this gentleman just pointed out. These are our 4 options: boy, 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 girl, girl, boy, girl, girl. So if we know at least one of the children is a girl, then we can eliminate the boy, boy option. We know that one can't exist. So at this point, we're left with 3 choices: boy, girl, girl, boy, and girl, girl. So now we know that the probability that the other child is a girl, that the girl, girl option is the biological sex of both children, they're both girls, is 1 out of 3. So you don't have to believe me, though. You don't have to trust the diagram or the eloquent way that was put earlier. We can do this with Python. So this is going to be a little bit of Python code to prove this. We're going to simulate it. And I know this is going to be a lot for people who are brand new, but what I want to do is walk through this example and kind of show you a little bit of Python as we go. Okay. And can everyone see this? I may not have thought about this too well. Okay. So, yeah, okay, they got the screens. Excellent, excellent. So in the code we have here, one of the big strengths of Python is that it comes with a ton of modules, and you can download modules as well. So what's a module? Module is code that other people have written that's going to help you do things. So one piece of code we'd like, if we're going to simulate this, is some way of coming up with a random number, so that we can say, oh, randomly, is this going to be a boy? Is it going to be a girl? So the module called random that helps us with that. We're going to create a function, and we'll do this a little bit later in a more basic way, called random kid. And we're going to call a method on from that random module called choice, and we're going to give it 2 options, boy or girl. We're going to set 3 variables, the 3 possible outcomes. Both are girls. The older girl is, sorry, these aren't the 3 possible outcomes, but that we're going to set these initial variables, and we're going to add to them to divide to get the probability that both are girls given that the first child is older, or both are girls given that either child is a girl, per our 2 questions. So what was the probability if the oldest child is a girl, what's the probability the second child is a girl, versus given that one of the 2 is a girl, what's the probability that the other is a girl? Okay. So we're going to create a for loop here, and we're going to use this underscore character for underscore in range, and that's 10,000 is the number. So we're just going to work our way through 10,000 trials. Underscore, I could have put anything here. Underscore is a convention that just tells Python, is for Python programmers who say, when I'm not using the variable. And we'll walk through a for loop later, but I could say something like, for letter in my first name, Gus, and then I could print that, and it would print out GUS. I'm going to call that random kid function, and I'm going to grab whether or not it's a boy or a girl, and then if this variable older equals girl, I'll add 1 to that. If that variable older is girl and younger is girl, so if they're both girls, add 1, and if it's older is girl or younger is girl, 1 of the 2, or instead of and, we'll add 1. And since this is kind of boring to talk through code, I'm just going to run this. So we'll print out our results, and we'll see that out of our trials, we had 4,990 older girls, and then 2,566 both were girls, so about a quarter of the time. Now, down here is where I printed out the probability. So probability that both are girls given that the older child is a girl, and the probability that both are girls given that either child is a girl. Does this look strange to you? Yeah, it's 0, right? We just said it's going to be 50% and then 33%. Why is that? Well, this is one of the fun quirks of Python version 2.7 that we were running. It defaults to integer division. So we need to import a second module. And this is boilerplate stuff, so we'll show you later. And now when we run the code, which I just did, we get the right answer here. So approximately 50%, and then approximately 33%. Kind of fun, I think. And for those who are curious, I got this example, came straight from a book called Data Science from Scratch with Python by Joel Grus, G-U-R-U-S, which is a phenomenal read. I would highly recommend it if you're just getting started. Okay. One kind of tidbit about IPython notebooks. You may see the cell I'm in right now. There's a kind of a P tag and then a closing P tag. When I hit Control-Enter, it prints out just a sentence. This is not Python code. This is HTML. It's what makes up a web page. One nice feature of these notebooks, if you use them, you can do analysis with them, but you can also use them for presentations. I can change this cell from here, code, to this cell, and I can say, I want this to be markdown. And now I can put HTML, I could write JavaScript. Anything that would go, that your web browser would be able to read and render, you can put here. So for example, just to go back up to the beginning, so you can see this a little clearer. Oops, it became the link. Sorry. This is what the header looks, that first cell looks like, where we have the image. It's actually an image that comes from IBM's version of Dropbox, along with some HTML. So you get a lot of flexibility with IPython, or now they're called, Jupyter Notebooks, to put in text and to write code. For those of us just getting started, right, we're here, we're just getting going. What this means is when you Google how to learn something in Python, or you're doing research about learning topics in Python, you'll often see these notebooks. You can just download them. They'll be great because you'll see people's instructions. You'll see their text just like a textbook, but you'll also be able to run the code interactively. So I think that's super helpful. Question? So this is why I kind of had my little diversion here at the beginning, because that dog can spin for, it sounds like a bad joke, but like 30 minutes. Yeah, I apologize. So just curious, has anyone been able to get into Data Scientist Workbench who's tried? Okay. And IPython Notebooks, if you were in? Jupyter Notebook, if you were in? Okay. Well, so just as a kind of an aside, when we did this last month, it was an introduction to R, and I got a lot of feedback afterwards. We kind of did this very detailed, here's everything about R. Here are all the data types. Here's control flow. And I think at the end it was kind of boring, and I got a lot of feedback that was basically like, hey, you didn't show me anything practical. You spent way too much time talking about just kind of the semantics and the syntax. So I'm going to try to switch it up tonight and give you more practical stuff, code that I've written and used. Unfortunately, that's also going to mean it may be, I don't know, just too esoteric or over your head. So we're going to kind of figure this out as we go. Maybe in month 3 for me, I'll get the right balance. All right, but now we will do a very brief intro into Python. So with Python 2.7, if I want to print something, I can just use the keyword print and some text, and I can use single quotes or double quotes, it doesn't matter. Oops, I need to escape this. Or, so if I have an apostrophe in my string, double quotes work great, and that works. Python data structures you'll probably use a lot are lists and dictionaries. So this is a list. It's just an ordered list of items. So if I want to access elements in this list, everything in Python is zero-based. So white space is the 0th element. Numbers would be the first. Strings the second. List the third, if I'm counting correctly. So even though this list has 5 elements in it, it would be 0 to 4. So if we're playing golf, it's not holes 1 to 18, it's holes 0 to 17. This is going to be a big thing in it's Python, and it's, I think, almost every other programming language except R and also except Excel. So for people who use Excel a lot, if you use a VLOOKUP formula and you say, I want to look up this cell in this range, and I start counting over my columns, I start at 1. In Python and pretty much everywhere else, you're going to start at 0. So if I wanted to print out, I'm going to say, hey, these are the topics we're going to talk about in our beginner Python: white space, numbers, strings, lists, and dictionaries. Let's start with the first one. That would be the 0th element, and I can put that into a print statement. I separate the text, my string, with quotes, and then I can use brackets to call the first item the 0th element, and it will then write, let's start with white space first. If I wanted to start with numbers first, I could change that to 1, and now we're starting with numbers. But we are, in fact, starting with white space. So what do I mean by white space? This is kind of weird. So for my Java programmer and others who've seen Java code and C, you'll see a lot of curly braces. Python, there are no curly braces. We use indentation. So in this little if statement here, which I didn't finish, else print, it might not work. Okay. Invalid syntax. So let's walk through this from the beginning. If I create an if statement or any type of control flow like a for loop, I will end it with a colon. The next line needs to be indented, or should be indented, 4 spaces. And in your IPython Notebook, it'll do that automatically. So if I hit return after an if statement or a for loop or a while loop, it will automatically move it over 4 spaces. If you use a different IDE, this is one area where a beginning programmer can get into a lot of trouble. If you're using a different text editor, then you start tabbing instead of using 4 spaces, Python may throw an error and say you have incorrect indentation. So just be very careful about that when you get started. It's a great way to waste half an hour trying to debug something. So I'd encourage you, if you stay within a notebook, you'll pretty much always be safe. If you move to a text file, you just need to be more mindful. You can also reset your settings in whatever text editor you're using. By text editor, I mean something like Notepad++, or if you like Linux, like Vim. Vim's available for Windows too. You can set tabs to equal 4 spaces, and you'll never have a problem. But I just want to point that out because it's always been kind of a pain in my existence, or the bane of my existence. So in this case, I set a variable called style equal to string 4 spaces. And now I just have an if statement here. And this if statement will be evaluated. So if style, if I want to evaluate something, how do I do inequality in Python? It's just equals equals. So if I set 1 equal sign, means this variable style equals this text. 2 equal signs means evaluate it true, false. And in Python, unlike, let's say, VBA, I don't have to specify what true equals. Whatever comes first that's indented will be done if true. If false, I can just include else, print, let's say, not 4 spaces. And let's change this to tabs. So now in this example of our first if statement, we have a variable called style set equal now to tabs, string. Could be anything. Could be just a bunch of gobbledygook. And we'll evaluate this. If style equals, if that variable is equal to the string 4 spaces, then print that's correct Python formatting. Else, if anything else happens, meaning if this Boolean statement is false, then print not 4 spaces. We're going to use a lot of if statements in Python. Unfortunately, the notebook will give you, it will let you get away with a lot of bad things. So in this example here, I've only indented one space and in this for loop, and in this example, I've indented 4 spaces. And unfortunately, this works, but please don't do this. And let's step through this too. So this is a for loop, and a for loop is a way of iterating through some type of iterable. In this case, I've got a list called range 5. So let's take a look at what range 5 equals. And for a second, I'm just going to add comments to my code here. This just means nothing's in this line doesn't exist anymore. Python won't read it. A hash or a pound symbol means comment. Range 5 gives me the first, from 0 to 5, well, 5 elements starting at 0 in a Python structure called a list. And I can loop through this. I can iterate through it. So in this example, for x in range 5, what's happening here, and I'll print out range 5 again so we can see it. We're going to work our way through this list. And the x can be anything. So it could be for, Bearcat in range 5 or in my list. Print that thing, whatever it is, just print it. So as we go through 0, 1, 2, 3, 4, each time we loop through, we'll print that item. So 0, 1, 2, 3, 4. Not super exciting, but we'll have more practical implications as we keep going. Another nice thing about notebooks, I don't always have to actually print things out. If I just return a calculation, so for example, print 2 plus 2 is 4, but I can just write beneath that 2 plus 3, and you'll get 5. If you do this in a text editor, this will not return anything to the console. So this is just kind of a notebook or shell feature. And also, it will only print out, just as you'll realize if you start to use these, whatever was the last non-print stated expression. So that last line, 2 plus 2, or I'm sorry, the first line, 2 plus 2, is not printed to the console. Any questions so far? I know this is painfully boring, and I'm very sorry. I'm still trying to find a good way to do this. Okay, we'll keep moving. Functions, kind of our last stop before we do something more fun. Functions. So I can create a function which is going to do something, and I do that I set that off with the keyword def. So I'm going to define a function. I give it a name, and then I say what arguments I want to provide in parentheses, and then a colon. So in this example, the very first function is called print_Gus, and it takes no arguments. And all it does, anyone want to guess? Print Gus. Yeah. Yeah, it's great. It's a great function. It's really, really impressive. Let's say I want to run this separately. I can come up here, insert, let's say insert cell above. I can now just copy and paste that into the cell above. And now I'm going to call this function. And since I'm in a notebook here, I can also use tab, which is really nice. I can tab complete. So I'm going to tab complete this function, open and close parentheses, and I'll run it. So then I got Gus. Beautiful. Great. Okay. So now let's make it more complicated. I'll insert another cell above. This time our function is going to take an argument called name. But I could also change this. I could make it whatever I want. I'll call it tiger, as long as I reference that variable in the body of my function. So now, and it prints out the argument I passed it. So I passed in a variable tiger, and then I told it to print what I passed in. So I passed in Bengal. If I change this to Siberian, I don't even know. I think there's a Siberian tiger. I could be wrong. Pretty sure it's a Bengal one. Anyway, last example, and I have 2 more, but I'm even kind of crying inside going through these. We can pass a function as an argument to a function. But you know what? That's kind of boring, and I want to skip that, actually. So I'm sorry. Get back to that. Okay. So now we're going to look at a few things that are not so beginner, but you're going to see these if you're doing any type of data analysis or data science with Python. So what I would encourage you, this is going to be my concluding point, but I'll bring it up now. I would encourage you, if you really want to learn Python for data science or to be useful, find a project that you'd like, something you'd like to accomplish, and Google or just research how to do whatever it is you want to do in Python. Google that. It's going to be extremely helpful. You're going to see tons of example code. There's a really good chance that whatever it is you're trying to do, someone has done. And it doesn't have to be data related. It's like, I want to build a website. How to build a web app in Python. You find an example. How to make a phone call. How to make a phone call in Python. There'll be an example. Like how to send an email, how to send a tweet, how to do those things in Python. How to work with Excel. That's what we'll see. I'll see a little bit of tonight. You can see how to do that in Python. So I would encourage you strongly, keep that in the back of your mind. And what I want to show you in this next section may not make a lot of sense, but there are things you're going to see if you do that. If you Google, how do I create a pivot table in Python? You might see some of these data structures. Okay, so we're going to look at one called a list comprehension. So I introduced this data structure called a list. So here we're going to create a new one called myturtles. And I'm not sure if I spelled these right, but I wasn't that big of a fan of the movies. So we went through a quick example of a for loop. Here's another one. So for friend in myturtles, print friend. I could change this again to anything. This could be for turtle in myturtles. And all I'm doing here is printing out the names of this list. I could do other things to this. I could also print, let's say, for example, there's a function called len that gives me the length of a string. I could use that. I could divide the length of the string by 2. Fun. But there's another way that you'll often see when you look at other people's Python code to print out or to iterate through a list. And that's called a list comprehension. And this is going to look a little strange. But this is almost the same thing as this. So here we have this syntax wrapped in brackets, friend for friend in myturtles. And I apologize, but we do have to kind of really nail this one down because it's going to come up a lot. So it looks weird, friend for friend in myturtles. What you want to do with these, what it's doing is it's printing out. It's the exact same thing as that for loop above us. It's printing, and let's make them turtles so it's consistent. Sorry, that would be better. So we want to read these. You want to read list comprehensions from right to left. So the opposite of how you would pretty much anything else in English. So when we read it right to left, we see for turtle in myturtles. Well, that looks like this. So these two lines, this line and that first line are the same. And then our second line of the for loop is print turtle. We just don't need the print statement here because it's going to stay inside of a list. So all we have is turtle. So that's a very basic list comprehension. If you read these from right to left, you'll be good. If you don't, it'll get harder. And they can get long and complicated. The reason why programmers like them is it's a great way of taking what could be a very nested and deep for loop and making it one line. It just can be kind of tough to read. But if you've at least seen this once and you start to read it from right to left, then I think you'll be in better shape than at least I was when I first got started. Okay. So now we have a data structure called a dictionary. And a dictionary is a set of key-value pairs that we can iterate over. So my friends, we'll give a few examples, dot keys. So each of these are the first value before the colon is a key. Sorry, the first value. The first thing, the first amount of text before the colon is a key. The stuff after that is a value. So Leonardo, Michelangelo, Raphael, Donatello, those are our keys. And then I tried to remember their actual weapons, but I couldn't. I don't think these are actually right. But those are the values that come in after the colon. And we can see that with my print myfriends.keys. And then print, let's see, myfriends.values. And those are our values. So now let's say we want to iterate over our dictionary. And one reason why, or one area where you'll frequently encounter dictionaries is if you read in a spreadsheet or a CSV file. So if you read in a spreadsheet or a CSV something that's tabular, you will likely read that in as a dictionary, because then you'll have a key, which is going to be your column header, and the value, which is whatever value is in the row that you're reading over. So if I read in a spreadsheet, I open this up and I start looping through each row, I may want to be able to reference the column header for that value. If I have 2 column headers or 4 column headers and I just know the order, that's fine. But if I don't know the order, if I have lots of them, it's a great way of being able to work with exactly the field you want to work with. So we're going to iterate through this dictionary just so you see an example. So this is a little bit different of a for loop. All right. So there's a method on these dictionaries called iter items, and I think the iter is for iterable. Basically, if I want to loop through a dictionary, I need to call that method open close parentheses, or this is one way. And I can pass in, instead of just for x in my list, I now have for k, v, for key value in my dictionary, print out key and value. And we can add logic and do things to it after that. So quick and dirty, that we've iterated through a list, we've iterated through a dictionary, we've seen a list, we've seen a dictionary, and we've seen a list comprehension. For giggles, because you might see them, there are also dictionary comprehensions, and that this just may be a little. Let's see if that returns. It does not. Live coding error, syntax error. Ooh on me. Okay. Ignore this. Sorry, I tried to come up with something on the spot and I blew it. Okay. At this point, I've made you suffer through about 30 minutes of introductory Python. I'm sorry. We're now going to take a look at some examples of doing things with data. And primarily, we're going to focus on gathering data. Ooh, that looks too scary to show. We're going to gather some data. And we're going to try to spend about 30 minutes on this, at which point that will put us at 7:30, and then we'll just kind of play around. Hopefully you'll be into Data Scientist Workbench by then. We can work. You can step through some of the tutorials, and we can either help each other or I can walk around. So I won't do too much more. What the goal here isn't that you're going to be able to see the code I wrote and copy it, but that I can introduce kind of 3 key ways of accessing data, or rather, specifically 2 ways of getting data on the web, one way of doing analysis on the web. And then one way of kind of hacking through a terrible assignment that I think many of us have probably gotten at work, where someone hands you like 400 spreadsheets and says, do something with these. So wouldn't it be nice if we could rip through them programmatically? Like, yes. And I had to do that 2 nights ago, so I thought I was going to add it in to this talk. So web scraping. How many people have heard of web scraping? Okay, we got a few. Right? So what we're doing here is web pages are made up of HTML. So like this notebook is a web page. We can look at it here. I just hit Control-Shift-I in my browser. This right here is what we're looking at up here, if that makes any sense. And I can click on some of these elements so you can see them. So this is this HTML code. So what does this mean? It means if I want to get data off of a web page, one way I can do that is I can scrape it. So when would I want to do that? So let's say, for example, I'm doing some analysis on a car dealer, and I want to buy some cars. So in Fairfax, I just found this site because I wanted something kind of ugly as an example, right? Like your boss says to you, not that your boss would ever say this to you, but I want to know what Fairfax Motors, whatever the name of this place is, tell me every car in their inventory and the price. How would you go about getting this data? Right, so there's like 86 of them when we set the number of, the per page limit to 100. So how would you go about getting this data, right? You could manually copy this into a spreadsheet. Maybe you could download it as HTML and try to parse it some other way. You just, save the file. So here's how we're going to do it with Python. Okay. There are a couple helpful libraries we need first. There's a very important library called request, which is what's going to allow us to easily make HTTP requests. So when I open a web page with my browser, I'm making a GET request. If I put in my username and password like I did on Data Scientist Workbench, I give them information, I'm making a POST request. Excuse me. Those are the two we need to know about, GET and POST. There are several others, but we don't care right now. GET and POST. Get data, post information, give it back to them. Here's the URL we just used. You will recognize it. I just copied this into the browser. We are going to set this equal to, so we have request to make the request. Now we need some way of parsing the HTML. We're going to use a library called LXML, and we're going to import a module, or we're going to import a package called HTML. This is what's going to help us decode this nastiness into actual data. So kind of our workflow here, step one is we create a variable, we set it equal to the URL, we're going to go scrape our data. And now we use the GET method of request. So this is just, I'm doing a GET just like I went to the web page. And now I have the response is here in this variable called fmotors. And this is going to be all of the data from that web page. I'm then going to pass that into a function from HTML, and I'm going to give it a bunch of strings, a giant block of strings, a bunch of text. And that is this fmotors variable .content, which just means just the string from the page. And when I pass this to HTML, I'm going to create a tree from that data. So this part you will have to read up on. It's not something we're going to quickly get you to understand. But the point being is I have a web page. I go to using request, I say, give me all of that data. Out of this web page, I now want just the strings, just the text of it, just the underlying HTML, pass that into another method that's going to decode this for us. And now we have this tree. And now with this tree, we can loop through this data and grab what we want. And I'm going to show you how we do this, because this kind of the way this is written, this is why I apologize in advance to my software engineers. I have no idea if this is good code or not. But I'll show you exactly how I wrote it, and it's not nearly as scary as it looks. So here's what I did. I came over to the used vehicle site. I opened in my browser with Control. We'll escape from this so we can show everybody. In Chrome and in Firefox, it's Control-Shift-I, and this brings up your web inspector. I clicked on this little thing over on the left, Select Element, and then I highlighted the fields that I wanted. So I want the name of the car, and I want the price. So let's, just for example, we'll click on price, because that's what we want. Chrome very nicely highlights this for me, and I can see it's inside of a span tag, nested way down inside of this HTML, way down in here, right? I then right-click, and I click Copy. And then out of these choices, I pick XPath. What is XPath? XPath is how we're going to, is this. This is what the tree allows us to get. And just for giggles, I will paste it in here so you can see. It gives me this, right? Which, if I move this over, looks very similar to the price. So this is, for that one specific car, this is the XPath location for that. So now I can extract the price from that HTML page just by right-clicking Copy. I just set it to a variable. You can see down here, it's almost the same. It's almost the same. There's just one thing that's different. And the one thing that's different is this variable car that I added in. So if we look at that XPath query, we can see that what's consistent here is this CT1 or CTL03. But then afterwards, and I should show you a few more examples, but you would find this out just by clicking around in here. Oops. If I click on, let's say, the next price, and then same thing, I go to where it's highlighted, right-click, copy XPath, come back over. We'll print this one out as well. Here's the next one. And here I can see that there's this random, in the URL string or in the XPath query, CTL03. So the first car was CTL02, the second car was CTL03. So if I want to get all of the cars, I'm going to start with the first one, 2, and I'm going to loop through some list of numbers until I get to the last car. So we had mentioned at the beginning, I said, hey, we have this list for X in range 5 is going to print out, or will give me a list, range 5 will give me 0, 1, 2, 3, 4. I can now loop through, I can just use that exact same syntax for range 2 to, I know ahead of time, if we scroll down to the bottom, we could see that the last car on the list is car 87. For I or X or anything, some number in range 2 to 87, I'm just going to add that in right here. And then I can go through and get all the pieces of information about the car. So I only have to write that line of that XPath query once. I found each thing I wanted, right-click, copy, set it equal to a variable, and now I found the piece that I can iterate on. I mean, so did they have to make it CTL 02, 03, 04? No. It could have been anything. I have no idea how they could have set this up. Right? This is just purely reactive. But it's one example of how you can just kind of relatively quickly copy once and now find the way to iterate through, instead of having to manually go in and copy and copy and copy. Okay. So what are we going to do with all of this information after we've grabbed it? So each pass through, I'm going to get the information associated for one car. What do I do then? Right? I've got everything from condition, color, miles per gallon, odometer. You know, we found where all those things were. Price. Title 1, 2, and 3, and 4 is just the title of the car was split into different elements. That isn't like anything related to the car's actual title, but just, 2012 Audi A4, et cetera. So what are we going to do with this information? We want to store it somewhere, right? What would be a data structure where if I have a name of something, like I know this is the engine, or let's say I know this is the name, and now I have the value of that, like Audi. What Python data structure that we've covered so far might be a good way of storing each row of data? This is a good test to see if I was able to explain this earlier. So what's that? Excellent, the dictionary. So because I have a key in that I know I'm grabbing the price. I'm grabbing the engine, V6, V4, there's no V4, V8. You can tell what I drive. The driveline, the transmission, or the odometer. We can create a dictionary right here. Where is my mouse? This is a blank dictionary called row, named row. This is going to be for each one of those cars. We're going to start adding information to this dictionary. If I want to create a key for a dictionary, I use brackets, and I put the text in for that key. So this is me. This is a blank dictionary. Now this dictionary has a key called price, and the value of that is this variable price. Now I'm doing a few things to it to clean it up a little bit, but we're creating a value here. So there's a price string colon some number, whatever it is, $28,000. That's what we're doing each time we loop through here. What you'll find yourself doing when you parse text in Python, oftentimes, is the strip function will remove things that are within the text. So with no arguments, it just removes spaces. If there's an extra comma, you can specify that this is removing a comma. The reason why I have ''.join is just kind of an idiosyncrasy of probably the bad code I wrote, but also of the fact that when I get my data back from this XPath function, it's in a list. And if you want to break a string out of a list, the Python way to do it is ''.join, meaning, or this could be anything. I'm saying join whatever this is to whatever's inside my list. So it's a little odd, but in this case, what I'm saying is no spaces, join. So if I had multiple items, I could say apostrophe, comma, space, or space, comma, ''.join, and it would break out each element of the list into a string and separate them with a space and a comma. But at the end of this, by the end of this line of code here, what we've done is we've gone through all of those variables we just grabbed, and now we've added them to a dictionary, and we've assigned them with these keys. So at this point now, we've gone through one row. So I'm at car 2. Now what do I do with my data, right? Because I have like 86 more cars to get through. So is there some kind of data structure we could use where if I just have a bunch of items, I could add them to it that we've covered so far? And I'll give you a hint. It's not a dictionary. So we want a data structure that's going to contain items. We're going to add items to it. Preferably keep our order. Okay, spreadsheet makes sense. That's a good answer, right? I could immediately write each of these rows to a spreadsheet. That would be one way to do it. That's interesting. And I hadn't thought of it. So maybe, now let's say though I want to do some more processing on all of my data before I wrote it to a spreadsheet, because we will write it to a spreadsheet. Just hadn't quite gotten there yet. So I was going to say, what we'll do is we're going to add these items, add this dictionary that we just created to a list. And we'll create a list of dictionaries. I don't know why, but this took me a really long time to get. And this kind of pattern of reading through some data, adding it to a dictionary, then for that dictionary, appending it to a list, and then starting over again, because each time we loop through this, our dictionary is going to go from, by this point, it's full of data. We go back up. We just finished our loop with car 2, which was where we began. Now we're at car 3, and our dictionary row becomes blank again. Right? We essentially clear it out. So this idea of every time we go through, we create a dictionary and then we add it to a list, took me a really long time to figure out, or at least like maybe wrap my head around, because it's not like people weren't telling me to do it this way. One of many ways you could kind of gather data. But it really bothered me, so that's why I'm taking so much time on this now. Our list is called my data, and we initialized it up here outside of the loop. We're not resetting the value. We're not clearing out the value of this list. It's just we create this once, and now we're going to add stuff to it every pass. So we loop through, we add to the list. Loop through, add to the list. Now we have a list full of dictionaries, and we can take a quick look at that. We have some list functions. So one thing with lists, I can say, show me the last item in a list, which is blank. The second item in a list, or let's say the first 10 items in a list. And so this is what we have. This is the data we've stored. This is the first car right here, our first pass through. This is the second. This is the third. And these correspond with the website. Okay. So this data structure right here is pretty ugly. Maybe we want to put this in a spreadsheet. There's a there's a Python library that is really good at working with tabular data. It's called Pandas. I have no idea why it's called Pandas, but it's the one you want to use. So if you get nothing out of tonight, it's Pandas. it is installed in Data Scientist Workbench. We import this module, and because pandas is long, the convention is to say import pandas as PD, which just means when I reference the pandas library, I'm referencing it as this moniker of PD. In the past, when we imported random, we just said import random, and then we said random.seed, random.etc. You can make this whatever you want. You can import pandas as cub or something. The reason, one of the big reasons, or probably one of two reasons, why people use pandas is this feature called a data frame. So a data frame is a great way for really quickly chewing through tabular data. So the first thing we're going to do is we're going to create a data frame with our data. I picked the dictionaries inside of a list because pandas will read, the data frame function will create a data frame easily from a list of dictionaries. So it'll extract the column headers and the data. And all I have to do is say pd.dataframe, because I imported this pandas as PD, and I created a variable called Fairfax_df for data frame. Now that I have a data frame, I shouldn't have given it away and shown what it looks like, I can take a look at the first 5 rows by calling the function head. And so this gives me my spreadsheet. Now it's not saved to Excel, it's not written out to a CSV, it still exists in memory here on my Python notebook, but I have something that I can manipulate. And there are 1,000,001 ways of chopping through data with pandas that are super fast and super exciting, and I'd encourage you to check it out. This is just one way. And we can look at the full thing too if we want in the browser. And we can look at this is all the information we just got. So we have our spreadsheet. So now finally, we're going to write this out to Excel. And the way we do that, there's a pandas function, Excel writer. We create the name of our Excel workbook, what we're going to write it to. We pass in this argument of an engine. We're saying we want to use this XLS writer to actually write it out. This is just boilerplate. I copied this, changed the name of the Excel file to what I wanted it to be. You can specify the sheet name inside your Excel workbook if you want to. The kind of germane thing here is at the end, writer.save. And when I run this, it creates this workbook. So we can go visit that if we want. And this was the spreadsheet we just created. And now we have it. Now we have it saved in Excel. And if you want to get rid of the row numbers here, that's just a quick configuration setting we can do easily. This is an end-to-end, I hope an end-to-end example of, I started with a problem. I want to gather all the data from this web page. I don't feel like manually copying it out. What can I do? Okay, Python can help me. I'm going to scrape the data. I used request, and I said, give me all this information. I then used this library, LXML, to parse out all the HTML from that web page that I just copied, that I just downloaded. And then I used Chrome. I said, oh no. Did we lose this? I don't know. Oh, no. I'll have to go interpretive dance for the rest of this code. Yeah. So the longest part was just the copy. So that probably took an hour to just find all of the elements with Xcopy. But after that, it was really, maybe another 20 minutes of just me making mistakes with fat fingering it. The nice thing is, though, well, maybe not the nice thing. So what I wanted to show you next was, let's say that piece of that example took an hour and a half, right? Okay. Now I go to a new web page. I have another car company I want to hit. Like, let's say, for example, I want to go to Edmunds and I want to get the true car value, their true car value for those cars, or for cars that I've scraped off of Craigslist. I have to now scrape that page I have to do the whole thing again, which is a huge pain. Or if those people had changed their website, if one of their web developers goes in and starts manipulating content, my code's going to break. So web scraping is like a really bad way to get data repetitively. You wouldn't want to put that inside of an application. So luckily for us, and what I was really hoping to show, there are ways of getting data from web applications where we can do it programmatically where it's not going to break. And those are called APIs, or an application programming interface. So when I use my phone and I go to Twitter, I go to the Twitter app, I'm using their graphical user interface. When I can do the same thing with code, and it's called the application programming interface. It's code talking to code. And that was going to be our next example. So we mentioned we're just going to go through it. I'll go through it verbally. There's a whiteboard. Yeah. Can we put this up? No. Probably needs a. So we'll give you the we'll go through a few steps. When I go into how many people use Twitter? I think several people. I hope. All right, we've got a few Twitter users. Okay. So Twitter displays tweets, right? That's kind of exciting. If I'm a business owner, for example, I might be interested in Twitter because let's say somebody is. Okay. Let me just make this a little quicker. Okay. So I'm a business owner. I own that car dealership. I want to know who's tweeting, I want a new BMW X5 because then I'm going to try to sell them mine, right? I want to find that out. Well, how could I find it out? I could get on my phone. I could go to Twitter's search feature, and I could search for BMW X5 and my zip code and see who's tweeting nearby about that, right? That would be one way to do it. And if I wanted to make sure that I was watching all the time, I could check back every 15 minutes or so, and I could look and look and look and look. But, go figure, maybe somebody tweets about it once a day at most. So I'd be spending a lot of time searching and not getting much data. Wish there were a better way. Go figure, there is. So if you go to like developer.twitter.com, something like that, you can register with them and say, I want to register with your API. They'll give you a key and a secret or tokens. This is just a way of verifying your identity. And then they're going to give you some URLs, just like we had that URL for the car company. But these URLs, if you were to put them into your browser, they will not render a web page for you. Instead, they're basically kind of like PO boxes or mailboxes where you're going to send a request and then you're going to get something back. So in the Twitter case, what I was going to show you was we can either pick a Twitter user or a topic, and we can say, Twitter, here's my key and here's my secret. Here are my credentials. I'm registered with you. You know who's making this request. Give me back the last 200 tweets of anyone who's mentioned BMW X5. Or if I'm like a big Justin Bieber fan, I could say something like, give me back Justin Bieber's last 200 tweets. And I could pull in not just what he tweeted or what that person tweeted, but did someone retweet them? Where did they tweet from? Did anyone like the post? So then we could build our spreadsheet from that. We could start to do some analytics. So that's one basic example of an API, but it's kind of a boring one because it's just Twitter, and not that many people, at least especially in government, are using Twitter data. But it's not going to break. So I can use this API concept. I have a few lines of code. I can make a request over and over again, and it will continue to work. And the company at least will tell me, hey, if we upgrade our code, if we write some new code, we'll let you know, and we'll make sure that the old version still works, so your program won't break. But there are more fun APIs that we can use. So another example for Edmunds. So people use Edmunds. It's like a car buying website. It gives you, among other things, like reviews, and they have a true value price for your car. So if you're familiar with Kelley Blue Book, those tend to be kind of high, whereas Edmunds has a different algorithm or a model they've created which says we can take into account like a better version of the car as well as your zip code and tell you what the private market is actually charging, what you could actually get for that. So if someone's selling their car and they're like, the Kelley Blue Book is $20,000, you check Edmunds, they may say, hey, for that zip code, it's actually more like 16. So that could help you through buying a used car. If we wanted to go through that and say, let's compare all 85 of those cars or however many we had and say, well, what's the Edmunds true value price for this? Edmunds very nice, I could go to the website and type them all in, right? But that would be a pain. Edmunds very nicely has an API available where I can pass in the make, the model, my zip code, the condition of the car, all of that information. They have documentation that tells me exactly what to type in and where. And I think that's probably another important point that I haven't emphasized. None of this code is stuff you have to think up. There's documentation with examples, and it'll say, copy this, paste your key here, paste your secret here, and then paste in the information you want. Whether it's Justin Bieber or BMW X5, you put in the data where they tell you to put it in, and you're going to get lots of information back. So it can be a really good way of getting lots of data. Excellent question. Excellent question. So we used request and the method .get earlier. And I mentioned there's a post request. So you can use requests most of the time with these services. So I'll pass in the URL, which they often call an endpoint. So like the Twitter URL for search tweets, along with some data. What's really nice is that for larger web applications like Twitter, like Edmunds, people have written sample code in whichever language you want to use, so like Python, where someone's written a function that's like get true value price of the car, and then I can just pass in the car I want and my credentials, and they'll give you an example. Yes. Yes, great question. So how do I get these credentials? I will search Twitter API or whatever I want plus API. I'll find the website. Usually they're generally like developer dot whatever the website name is. So like developer.twitter.com I believe is the URL to go, and you'll have to register. The reason why they want you to register is because, and not all APIs require you to do this. So GitHub, for example, is a website for sharing code. They have an API available. You do not have to authenticate with them. You can just hit the API. Google, for example, if you wanted to like geotag, if you want to say what's the lat long of this location, you do not have to pass in any credentials. But for Twitter, some of those services they do just because they want to know if you're hitting them like 1,000 times in a row. And I think even 1,000 would be fine. It's more like on the hundreds of thousands where they'll say, no, you need to slow down. So those are kind of two examples of how we can use APIs. So how many people have heard of Watson? And I'll kind of wrap up with this one. Maybe Watson, right? Like, so Watson is supposedly this, this. Can we take AI? Can we make a computer think like a person, right? That's the idea. Cognitive computing is the buzzword IBM is pushing. So Watson has a series of APIs that IBM has opened up that developers can use for free. So from a data science standpoint, you can spend a lot of time doing some really complicated work to try to replicate some of the things that Watson will just give you, and you can try. I'm not saying they're great, but like for example, if you wanted to do speech-to-text translation, like you had an audio file, they have an API available where you could do that. Woo! Awesome. Thank you. Awesome. Okay. Where should we start? Okay, it's 7:30 now, so I want to be quick about this. I don't want to take up too much of your time. Please don't steal my username or my key and secret. You're never supposed to share these with people. So yeah, do not post these online because then people can make requests as you. But so in this example, we're going to use the Twitter API, and I downloaded a Python package called Python-Twitter that gave me a function called API. And when I pass into API my key and secret, and then this other thing, token, key, and secret, what Twitter has given me, I can now get access to all of these functions. So you'll see here, these first 4 lines, all of this right here, this is all copied right from the documentation for this library. I just replaced these pieces of information with my own. I'm going to decide I want to get a user timeline. So I picked the user Kanye West, and then I've called this function get user timeline. I pass in screen name equals user, and we can run this, and let's see if it works. Okay. So anyone want to see what Kanye's last 200 tweets were? Statuses. I think is it .json? Nope. If you don't know, oh, this is embarrassing. What is the method for statuses? I'll have to scroll down in my own code to see it. Oh, x.text. probably should explain this. Okay. Let's step back through that really quickly. This is going to be, I'll be fast because it's boring, but it's helpful. So I set this variable statuses. I tried to see what it would give me. It printed out this list of all these objects, twitter.status at blah, 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 some hash, right? So then I said, okay, maybe there's a method on this I can call. So I just hit dot and then tab, and I started looking for methods. And I didn't see any, but in the back of my mind, even though I knew that it didn't show me a method available, I said, well, I think there's this method called text. And I got this attribute error. Python threw an exception. And it said, list object has no attribute text. And if you notice, I probably did this twice just because I'm hard-headed, but the computer's never wrong, right? You're wrong. I was wrong. So I was saying, hey, I'm trying to call method text, but they're telling me this is a list. It has no method called text. If we want to check what type of object we have, in this case, I can use a function called type to confirm that this is, in fact, a list. So if it's a list and I want to iterate through it, one way we can do that is with a for loop or with a list comprehension. So at this point I said, oh, I've got a list. I can't call this method text. I got an error. So now I can say for tweet in statuses, and now I have this variable tweet, and let's see if I can, oh, it won't let me dot complete on it. But now that I remember, oh, there's this for tweet in statuses, right? Oh, did this time out? I'm sorry, I think what is going on? Ah, there we go, okay. So there can be a little bit of a lag, and what I ended up doing here, I just moved a little too quickly, and there was a slight lag. This is what each of those tweets looks like. So it's this giant, it's a JSON structure, which is just a series of Python lists and dictionaries. Keys and values, mostly dictionaries with a list or two in there, with a bunch of data. The one we want is to see the actual value is here, and I know you wouldn't pick this out just right away, but you look for it, is text. You know, so now we have, I love Rick Owens' bed design, but the back is too high. You know, we get the joy of Kanye. Man, that'd be so Kanye. Great stuff, right? So wonderful. Okay, we're going to get to the Watson thing because I think that's more fun. For comparison's sake, I went over and grabbed a bunch of tweets from Daily Plato, which are just little tidbits of Plato's writings. Somebody puts into 140 characters or less. And now we're going to use the Watson API. So Watson has a service called Personality Insights. And this is kind of a silly thing. I don't know what the business application is, but it's a Watson feature. So if you give Watson a bunch of text about a person, they'll say, we can tell you like what kind of person whoever wrote this is. So it doesn't work well for like fiction, but let's say you had like a presidential address, or I guess if you had, you know, some kind of maybe a letter from a CEO to shareholders or something, and you wanted to break that down and say, what is this person really about? You could do some very complicated natural language processing on your own, or you could check out this IBM Watson service. And in order to do that, I registered with Watson, and now I'm going to make a post request. And I'm going to just follow the code, the example code they gave me. So before we did get request to get data, post request to give data. And I'm going to go to a URL, which I have probably defined up here. Where's my URL? Here, this is the Watson Personality Insights API. Sorry, I got lost in my own code. I'm going to pass in a username and password, which is a key and a value. And then this is a little bit more low level. They tell me I have to pass in this headers and tell them that I'm giving them this value here of text. That's plain text. Other options you'll see a lot will be JSON. But this is all from their site. They were saying, here's the way to do it. And then finally, I'm going to pass in a variable here, which is just, it's called yay text, which is the Kanye tweets that I just put into one block of strings. So that's the format they wanted. They just wanted strings, and I just skipped the step of showing you guys for the sake of time how I did that. But I have a block of strings. I took the tweets, strings, we're passing it in. So when I do this, this variable here, response, is going to contain what Watson gives me back. So I made this post request, Watson, it's Gus, here's my username, my password, here's a bunch of Kanye tweets, can you tell me about his personality? They'll give me back this response, and they'll give it to me in a format called JSON, which is what's going to look like Python dictionaries. I parse that with a library called JSON in Python, and I'm going to load in the text from that response. And now we're going to iterate through it and go figure it's a series of dictionaries, and we're going to look for some funny things. So just to make it slightly more humorous, I'll show you what they tell us about Kanye, is that his personality ranks in the 90th percentile. Probably this is down here. And this is supposed to be out of like all people. His values, his sense of values is in the 86th percentile. So that might be maybe a little surprising to people, but based on his tweets, you know, Kanye, a man of values. I did the same thing with Donald Trump, but the results are a little too scary to share. Thankfully, on artistic interest, he scored very low. On emotionality, I was surprised. 32nd percentile. I would have thought he'd have been higher. Authority challenging, 61st percentile. I think that makes sense. Achievement striving, 49th. I think he would blister at that. Another fun tidbit, Justin Bieber scores in the 91st percentile for determination or self-discipline. Not a trait I probably would have associated with him. Plato, self-discipline, 41st percentile. So it's not a perfect service, right? You're probably, it's not necessarily the greatest thing. But it's just a way of saying, hey, there's so much out there that you can go forth and really do and learn a ton about all these different concepts for doing data science, for different types of machine learning, for natural language processing. But you can also find APIs available that will help with a lot of these tasks, where you can write 5 lines or 6 lines of code that I just copied from their website, and I have something. You know, is it the greatest thing in the world? No, but it's getting me there, right? It's getting me there. So that was just kind of what I wanted to close with, were these examples. And actually, maybe one more if it's okay. This was just a pain point for me the other night, so I wanted to share it because I was annoyed. So this is less data science and more data wrangling, but I found myself in possession of some 423 Excel spreadsheets. No, I'm sorry, 427 Excel spreadsheets. Each containing, a bunch of, they look like this, that contained a bunch of weather data. And I was told that dates back 10 years, daily weather data that goes back 10 years for 427 locations. And I was told to provide the monthly average over all 10 years for all locations. And they're all in these different worksheets. So it's like, oh, how to do that, right? I don't want to have to open up each of these workbooks and use some Excel formulas, or even try to write, maybe you could write a macro. So, and I was like, it was also like after 6. So it was like, it's really more of a bummer, I'm doing this in the evening, and I could be doing something more fun. But luckily, Python was there to save the day, right? So the naming convention, the first thing I need to do for this problem is I need to be able to open up all the workbooks, right? And you'll probably find yourself in a situation like this. The naming convention, thankfully, was standardized. So they all looked like some number underscore ID underscore weather underscore data. So this part of each workbook name is the same. The first part was just a number. So I can use my for loop, and I can iterate through a list of numbers and just add that to the beginning of the name, and now I have the file path. I have the name of the file. So now I can access each file. One function I didn't show you that you'll use all the time is str for string. So when I loop through this range of numbers, 1 to 428, if I try to append a number to text, or append, I'm sorry, if I try to add them, this is addition, plus sign, it'll give me an error. You can't add numbers and strings. But I can just make that number a string, and now I can add it. Second thing I didn't show you that you might be interested in is a try except loop. So Python kind of has this idea that they want you to basically, it sounds weird, but try something, and if it throws an error, then do something else. But don't check for the error first. Like, they're more like beg forgiveness, don't ask permission. So that control structure is try and accept some error, like we saw when I tried to call that method text on the list that didn't have it. It's an attribute error. That's an exception, an attribute error. I can specify, try this, and if you see an attribute error, then do this. Or if you see any error at all, then do this. That's probably not a good way to go, but you can specify. So try, and if you see this error, do something else. So in this case, I noticed after the first time I looped through this that I didn't actually have 428 contiguous workbooks. Some numbers were missing. So like 327 was blank. So if I tried to read in 327_ID, blah, 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 it was going to throw an error because that workbook doesn't exist, right? And in this case, it was going to throw an IO error because it's going to say, I can't find what you're looking for. So I'm catching that exception, and I'm just printing to the screen which of these workbooks don't exist, and then I'll go back to the beginning of my loop. So as I start looping through, I'll start at like 1 ID weather data.xlsx, and then I'll say, okay, read in that Excel file, accept it. If you can't find it, then just print out, oh wait, file 201 doesn't exist, 307 doesn't exist, 394 doesn't exist. Go to the next one. Helpful way of just kind of working through an issue. But the interesting code here is PD for pandas. Remember pandas? It has a method, not only can we write to Excel, we can also read Excel, right into a data frame. So I called this method read Excel on the file. It reads in my table. Now I've got a data frame. And now I'm doing some manipulation to the actual data frame. This first part, we're going to ignore that first line where it says the key is foo. All I'm doing now is I'm basically creating what looks like our dictionary. It's also it's a column in the data frame. But I'm saying my daily temperature is going to be equal to, in the spreadsheet, we didn't have just one temperature. We had a max and a min. So I'm going to create my daily average. And just to do that, I said, okay, max temperature, temp max plus the min divided by 2 gives me the average. Same thing for humidity. So now I have daily averages for each one. I use this function group by, so I can group by the dates. And now I get this great pandas function called aggregate, which will just let me use a function and aggregate it across my whole table. So in this case, I can say, call the function mean for average across the data for wind, precipitation, day temperature, and humidity, which I just created. So I can say average all of that data by these dates that I specified, by the month, for all of the months within the spreadsheet. And then when you're finished, append it to a new data frame and do it again. And then at the very end of this, I just wrote it all out to a CSV. Or I could have written it out to an Excel file so that I had my monthly data. And I think I can show you that one too. So it should still be here. So in the end, I got this, which is now for each location, I have a month instead of a day. And this is all of my locations, all 56, well, divided by the years, but all 427 locations by each month in the 10 years. So that saved a lot of time, and I was really happy about that. And is this the best way to do it? Is this the cleanest way to do it? Absolutely not. But it worked, and I got to go drink a beer and hang out. So it's a win. So I noticed, yes, question in the back. Okay, great question. So there was another important library that I didn't talk about yet, which is called NumPy, and it's a way for doing fast data processing on arrays. Data frames are essentially collections of these arrays. So the function we're calling is average or mean is on a column of data, and it just so happens that that's a NumPy function. How did I get that? I Googled, how do I take an average of monthly data in pandas? I might even have the history, like right in my history. And Google told me, oh, use this np.mean function after you do a group by your date, and then aggregate and use NumPy. So I imported that library. Go up to it. Where did I import that? I promise it's in here somewhere. Here we go. And you can, and I apologize for showing you all this extra code. None of that was doing anything. This is all just me doing different variations. But this is that library, NumPy. And I just, it's convention to set it, to refer to it as NP. I could have said import NumPy and then NumPy.mean. Any other questions about that? Mm-hmm. Great question. So the question, and I'll repeat it. So the question was, when you're looping through each row in the spreadsheet, how do you know where to start, and how do you know when to stop? And if you've ever written a VBA macro, oh wow, that's bad. I spent a lot of time writing VBA macros. If you loop through a spreadsheet, you have to specify where you're starting and where you're stopping for the most part. There are kind of some ways around it, but a common pattern is to go. You have to use a function to go to the bottom of your spreadsheet, come back up and find the last piece of data, and then say that's where I'm ending. The beauty of pandas is I didn't have to know it all. It did that for me. So when I said pandas read _ Excel, it read it all into a table. Then I didn't even have to iterate over it. The pandas functions, this mean here, or when I specified my file, I'm just adding together each row of data, the max and the min. Beautiful part of pandas, I'm not looping at all, actually. At this point, I have one line of code for one workbook. Pandas will automatically, because it's a data frame, because some really smart guy wrote a lot of really helpful code, it will take that and run it across all of my data in the table. It makes it really easy. I don't have to loop through the workbook. I could, and you'll spend a lot of time doing that, looping through CSVs. So to answer that question, if I weren't using pandas, I would say something like for row in my file. I would read that file in. The convention for that, and I'm not going to run this code because I already embarrassed myself enough running code that didn't work. But I would do something like with open my file, and this could be a full path, so like C data, like my file, .csv, for example, in strings as F, and then I would read this into something. So I would say or I could just iterate through this, for row in F, and now we'll say do something, print, say row, whatever. It will loop until it hits the last row, and then it will stop. Or, I'm sorry, if that's a regular file, to the last line. Python will do that. But the nice thing, so instead of having to set, okay, from here, grab the date, or grab the dates, grab the temperatures, average them, aggregate, I could just say with pandas, one line, aggregate the temperatures, and it does it across everything. And I can repeat the questions. I've been trying to do that. Oh, okay. Uh-oh.
On the Excel spreadsheets that you talked about, there are more than 300 of them or so. How long did it take to run it? You asked number one question. How fast was it able to process it and give you what you wanted?
Yeah.
The other question, I had to do something similar to this, but I used VB code, more than 600 lines of code.
I have really attractive consulting rates, so.
Yeah, it took a lot of effort. One of the issues that I had was looping through columns.
Yeah.
I needed to loop through columns instead of rows.
Yeah.
So is there a way to do something of that sort that's easy? Last I be able to get a copy of this at the end?
Yeah, so, yes.
Thank you.
Okay, great. So let's start with the first question. I'm sorry, I already forgot the first one.
Time. How long will it take to process performance? Yeah.
I didn't time this, but the Python, and this is the engineering that I don't understand, but the NumPy library and the Pandas libraries are written in C, an old programming language that's very fast. So it was actually extremely quick. I think it was on the order of seconds. I wasn't thinking about it. Conversely, to make those spreadsheets were generated from a series of API calls. So each of those data points was a call out to a service, get back the weather data. That in total took something like 36 hours to run, because it was single calls to get each of those, to get the data back. And a lot of that isn't it's both like, okay, across the network to them, but then it's processing on their end and then returned to me. Second, so very quick. Pandas, super fast. Question 2 was columns, iterating over columns. Yeah, so there are a couple ways. If you read your data into a dictionary, which would be one way of, we were kind of showing that here. We would say something like, my data, let's assume that my file is your spreadsheet. There is inside the CSV module that you'll need to import, so it'd be something like this, if I spell it right. Import CSV. There's a method called dictReader, and I could say we're going to read from this file. And dictionary reader is just going to take, if you have that tabular data, it's going to extract the column headers as keys, and then it'll add as values every piece of information in the spreadsheet, every value. So now we can loop through it. So specifically, how do we get to get the key values? We could say something like, for row in my data, if we wanted to do it on a row-by-row basis, which is what I assume you mean, like, I only care about the column if this row has it, maybe. Yeah, then you could say something like row.keys, and now you would have all of the keys. You could apply some logic to it. Like, you could add an additional key if you wanted to, or you could delete something. Well, we wouldn't really delete. We would probably write to a different structure. But you would get to it by, if you read it in so if you read your spreadsheet in, your CSV in as a dictionary, then you would have, your column headers would be your keys. You could access those with any dictionary method that worked on keys, like .keys. You can iterate through. And you could say something like for K or for key in row.keys, and now you would have access to each of those keys. That would be the way. There's also, in the data frame itself, Pandas has a method, I believe it's called like .columns. So dataframe.columns, and now you have your columns. And you can attack from there. Okay, access to this information. I can't give you access to the spreadsheets. I probably shouldn't even have shown them, but it's just like it's something I was doing this week. But what I will do is I will copy up the API calls. I'll take out my keys and secrets, and I will combine those into this Introduction to Data Science with Python workbook, and then we will post that. There's also one of the Toronto guy who couldn't make it. He did this meetup in Toronto 2 days ago. He has a totally different workbook that's fantastic. The reason I didn't present his was just because I think his is so good. You can read it on your own and learn it. So I just wanted to cover a few different topics. But I'll make sure to include his as well. And what we'll do is, what you're going to do with these notebooks, here's kind of how you load them. Oh, good. Okay. So I'm here in my data scientist workbench, and I will just go to wherever I've downloaded that workbook, and you'll notice these are called IPython Notebooks have the file extension .ipynb. If you have Adobe installed, it may try to open them up on your own. But all I have to do to load one of these workbooks in a data scientist workbench is literally drag it from, in my example, Windows Explorer. And let me make this small so you guys can see it pop up. I literally just drag it and drop it onto the screen. And now it will upload, and I'll have that notebook in the cloud in Data Scientist Workbench. So I'll post these files. You'll download them. You'll go into Data Scientist Workbench, drag it and drop it inside of an IPython, after you click on IPython Notebook, sorry, I skipped one step. Log into Data Scientist Workbench, go to IPython Jupyter Notebooks, which is, where are we? Let's go back to the home page. Jupyter Notebook, and then it will show up. And you can see your notebooks over here on the left. Here's the one I just dropped, Introduction to Data Scientist. I keep saying Data Scientist, Introduction to Data Science Python. Now it will load. Yeah. Oh, great question. Okay, so the question was, hey, if you want to interact with different databases, relational databases, NoSQL databases. NoSQL databases are these key value stores generally used for Hadoop for distributed processing for big data. There are tons of libraries that smart developers have written and open source for free. So I know there are like out of the box you'll have access to SQLite, which is a small database that often comes, I think even comes prepackaged with Python. But there are libraries for MySQL. There are libraries for most of the Hadoop for NoSQL databases. MongoDB, if you're interested, MongoDB has great Python support as an example. Oh yeah, definitely. Yeah. And if you get into data frames, you can actually, well, yeah, yes. You can write SQL in Python, or you can use, if you go out and build a web app and you're trying to communicate with your Oracle backend, there's a query language that basically gives you an object, like an object-oriented way of making SQL queries. So you would be referencing properties on a table instead of like select star from this. It would be like this dot thing. That was really helpful. Question in the back.
Can you give us a quick drive-through on this IPython Notebook? I mean, I'm at the main screen, and I haven't seen anything that looks like what you're doing.
Okay, excellent. Yeah, absolutely. And it looks like mine is still loading. So I'm here. Is this the main screen? No? Or are you here? Excellent. Okay. So you clicked here. All right. No, does it look like this? Perfect. Okay. So they just the IBM guys have posted a series of notebooks that you can use. So if we wanted to start with the basics, we're going to just come over here. I'm going to click on this notebook. Now, depending on like how, if we're all hitting Wi-Fi at the same time, this could be a little slow. And it looks like it is slow. But if we were at home, this would go a lot faster. And what you'll see show up here is something that's going to look like these notebooks here. That's what will be rendered. Are you not when you click on one of those notebooks? Are you not seeing that? Yeah, that sounds right. Can you double click inside any of the cells? I apologize. So the reason why I ran mine locally is because it can take a while sometimes. So I know I'm kind of cheating. Oh, where will you find it? It'll be here. It'll show up in this little drop down here. So that's where the notebook will be. Sorry, the question was, hey, when I drag and drop the IPython Notebook and I put it into Data Scientist Workbench, where will it be? Over here on the right, there's a recent notebooks. Boom. That's the one I created. And I do apologize that this is taking so long to render. If you want to install a local version of just the underlying software with notebooks, there's a distribution of Python called Anaconda. Kind of clever, right? Python Anaconda. Anaconda, and if you download whatever the right version for your operating system and architecture, it will come with Jupyter Notebooks, which is what I'm running locally. And it's really nice. It's a GUI installer, so when you download the Anaconda installation, it's an exe file. You double-click on it, next, all the defaults. It'll set all of your environment variables, and then you'll have Python installed on your computer, and you can come over to, if on Windows, for example, and I can say Anaconda, Jupyter Notebook. Now I can run the notebooks locally. And if this were to finish loading, you could also do it in the cloud. You could move it up move them down. And again, I do apologize that this is not returned. If we go back to the welcome screen, these are all IPython Jupyter notebooks you can use, and they include in tutorials. So it may look like text. I'm hoping that's what you're seeing in the back, is what looks just like text. But that's that HTML code that is this stuff, which is actually a cell in the notebook. I just picked Markdown or HTML instead of code. But you can come up and you should have the tabs to insert. You can insert a cell above and say, oh, print, this. Oops, that's not right. And you're actually right. You're able to write code. I'd say, so yeah, if I haven't hammered it enough, if you want to learn more, Data Scientist Workbench, or how to do X with Python. The topics we didn't give any time to, and I do apologize, would be basically everything related to machine learning, which is a huge part of data science, the actual analysis piece. We spent a lot of time on just the basic syntax of Python, how to gather data, and then how to get data from the web via web scraping or APIs. And then for our kind of analysis piece, I really cheated and said, hey, there's this whole Watson API you can use. Maybe check that out first, and then you can start looking at some different approaches to analysis with code. Wow, can't speak. There are great machine learning tutorials on Kaggle. If you go, Kaggle is a data science competition site. Kaggle. They have some great examples. Their introductory example for Python walks you through a random forest algorithm. And the documentation is good, the code is great. I would highly recommend you check that out as well to get into the kind of the more hardcore analysis that we didn't touch on tonight. Kaggle. Really, really oddly named. Kaggle. And these are also a nice thing to put on your resume because you can do one of the competitions and then be like, I'm a Kaggle competitor. And hiring managers will think that's cool. Yes. Yes, ma'am. You could do this to open if you want. Yes, you could do. So I'm sorry. The blue. This is a great question. The question was if we want to open up. If you'd like to open up a notebook, you have the option of opening up a notebook that is going to run Python 2, what we were doing, Scala, which is a different programming language, R, another programming language, or Python 3, which is the next version of Python that's not backwards compatible with Python 2. This is going to open up, and it probably won't render before we all retire, but this is going to open up a blank IPython notebook that you could use. That's what the blue tab is going to do. If you'd like to access any of the existing notebooks, you'd find those in the welcome screen, and once you open them and edit them, it will save automatically, and they'll be here under this little greater than symbol as your recent notebooks. That's a great question. I don't know. I've pulled down some pretty big files. I haven't run into it yet. This product is also in beta, so if you find bugs, like I found some bugs, I just emailed them. There's a help tab here. They're very responsive. So as long as, especially if it's business hours, and if you tell them, hey, I'm in a tutorial or I'm in an IBM class and I can't access this, they'll respond really quickly. That's actually how I got here, was because I kept sending them messages. So they were like, who's this guy? Yeah, yeah. So you can reach out to them if you find something that either doesn't work or it's just, hey, this thing hasn't loaded. What's going on? I probably should message them now. But I think Toronto is still Eastern time, so I'm guessing they're probably not going to respond until tomorrow. Other questions? 8:05. I was going to say, I'm sorry for holding everyone this long. I really appreciate you sticking in there. If anyone wants to stick around and do some more work, I'm happy to kind of, chat and debug and whatever else. But otherwise, thank you so much. Thank you, Elena. Thank you, UMUC.